Hi friends, welcome to GMAT Points video series. I'm Saili Kale. In this particular video, we'll be doing the second part of graphics interpretation. So we have already covered charts. In this particular video, we'll be covering the quantitative diagrams. Specifically, we'll take a look at two types of diagrams, Venn diagrams and network diagrams. So let's start with Venn diagrams. So a lot of you who would be aware of set theory would have already come across Venn diagrams. Venn diagrams are a visual representation of sets. So if you have a universal set, that is the set of all possible items, and a set A is basically a subset of the universal set. There is another set B which is also a subset of universal set, and this Venn diagram shows what are the number of elements that are common between A and B. This particular part shows you what are the elements that are part of only B, and this part over here, this part I would say like this, it's the visual representation of the number of elements that are part of only A. Now if you are taking a summation of only A plus A and B plus only B, what do you get? You get basically the summation, or rather the union of two sets. So this is equal to A union B. Now instead of taking all of this, if I take all the elements that are not part of either A or B, what do I get? I get the intersection of A dash and B dash, that is not part of A nor part of B. So this dotted part that I just do is essentially intersection of the part which is not part of A, not part of B. Not part of A and B, if I say it's not part of A and B. If I say not part of A and B, it basically is all the section other than A and B. So other than this area over here, you get everything else. So essentially whenever you are given any information, the first thing you have to do is what? You have to draw this union set, universal set. If there are two sets defined, you should say that, okay, first let me find out what is my number of elements in all. Okay, so this is my universal set. Suppose there are say 100 students. Out of these say 70 study maths and say study science. So I am representing the universal set, which is the set of all possible students. There are only 100 students, so that is the universal set. Of these 100 students, 70 study maths. Of these 100 students, 50 study science. Now we can infer that clearly some who study maths also study science, because the sum of maths and science is 120, which is greater than the number of students. So therefore there is definitely an overlap of students who study both maths and science. So suppose 40 students study both maths and science. Now if 40 students study both maths and science, how many study only science? That would be this 50 minus 40, so this would be 10. Similarly, if 70 study maths and 40 study both maths and science, 70 minus 40, that is 30 study both only maths as such. Now if this is the distribution, 30 over here, 40 over here, 10 over here, so how many study either maths or science? So that would be basically union of all of this, so that would be 70 plus 10. So 80 study maths, either maths or science as such. How many study neither? There are 100 students, right? So if 80 study either of these two topics, 20 study neither of these two topics. So the neither part has to be put outside over here, which is like not part of either set. This is basically how you fill a Venn diagram when you are given two set Venn diagram. You can follow the same methodology for three set Venn diagram. So suppose instead of having two topics, if I had three topics, and if that was the distribution given was like this. Now for three set Venn diagram, you have to use the same method. So consider three subjects instead of two subjects. Suppose again I have like 100 students in my school, and suppose there are three subjects, I say maths, science and geography. So these are the three subjects, okay. Now suppose I am told that 20 students study all three subjects. Suppose 70 study maths in all, say 50 study science in all, and say 80 study geography in all, and 20 study all three topics. So when I say 20 study all three topics, I should put it in the area which is the overlap of all three sets as such, which is the overlap of all three circles, which is this part over here. So that is why I put 20 there. Now suppose I am told that say 10 study maths and science but not geography. So where should I put it? This part is the overlap of maths and science but not geography. So I should put 10 over here. If I am told that say 10 study science and geography but not maths, This is the area which is the overlap of science and geography, but not maths. So this is 10 over here. So how many study only science? See, in this entire circle, I have to accommodate 50 people. 10, 20, 10. So that is a total of 40 have already been accommodated in these pieces as such. So the remaining 10 have to be accommodated over here. So 10 students study only science. So suppose if I am told that say 40 students study geography and maths but do not study science. If that is the information that is given to me, then what would be the values of those who study only maths? See, over here I have to accommodate 70 students. 10 plus 20 is 30, 30 plus 40 is 70, 70 are already accommodated, which means that there is no student who studies only maths. I have to accommodate 80 students in this circle over here. 40, 60, 70 are already accommodated. So there will be 10 students who are studying only geography. So over here you have to remember this number is equal to the sum of all the numbers in this particular circle. This number is the sum of all the numbers in this circle, and this number over here is the sum of all numbers in this particular circle. Okay. So using that you can infer any of the missing values. Now using this information, can you tell me how many students are studying neither of the three topics? So how many are studying either maths or science or geography? How many are studying only maths? 70 are studying, so how many are studying maths? There are 70 who are studying maths. So over here there are 70. How many are studying science but not maths? Science plus, but not maths would be this over here, 10 over here plus 10 over here. So that is another 20. How many are studying geography but not maths or science? So that is another 10 over here. So that means a total of 100 students are studying either of these three subjects as such, which means that the number of students who are studying neither of these three subjects is 0. So the value of n that is not part of any of these three sets is 0. So this is basically how you fill in a Venn diagram. When you draw a Venn diagram, show the area of overlap. The overlap, the number that you put in the overlap is the number of people who are doing A and B but not C, or A and B and C. So basically the area of overlap determines how many people, that visually shows how many people are part of that particular set as such, or part of a set as such. Okay. So this is the basic idea of a Venn diagram, a 2-set Venn diagram and a 3-set Venn diagram. Now when it comes to GMAT Venn diagrams, you can get a simple Venn diagram like this, it is possible. But generally what they do is, instead of giving numbers, they try to depict this pictographically. So how would they depict this pictographically? So suppose the same diagram that I had drawn. So this is U, which has 100, and this is maths, science and say geography. I would say that each star represents 10 students. Okay. So I had how many stars over here? I will have 2 stars over here. I will have 1 star over here, 1 star over here. This is maths, science and geography. There are 70 students in maths, 50 students in science, and say a total of 80 students in geography. This might not be given as such. So this information might not be given, but essentially each star represents 10 students. So instead of actually giving you numbers directly, they will give you information like this. So there will be 1, 2, 3, 4, 5 stars. So from that you have to infer that okay, there are 50 students in science. Over here you will have 1, 2, 3, 4 stars, and over here 1 more star. So using this you will say 4 stars over here plus 2 stars, 6 stars, 7 stars, 8 stars. Each star is 10 students. So geography has 80 students. Similarly over here there will be like an empty space over here. So that would be 4 plus 2 plus 1. So that is 7 stars. So there will be 70 students studying maths. So using stars instead of numbers, or using any kind of symbol, they'll show you the number of or the frequency of any particular number of times any particular element occurs, or the number of elements in a particular part of the set. So this is the only difference that we see in the Venn diagrams. You can get plain Venn diagrams that I have explained earlier, or you can get the Venn diagrams of this type in GMAT. So this is the only thing that you should remember. Plain simple Venn diagrams have to be solved, and using that you have to answer the questions. So let's take a look at a simple question based on Venn diagrams. So in this we are given that each of these symbols is equal to 10 students. So the first circle is 30 years of age or older, and this part of the circle is no high school diploma. So this refers to a pictograph of a survey of students at Central Community College. Each symbol represents 10 students in a sample of 300. So I will draw mine. I am actually more comfortable with my Venn diagram. So my universal set is how much? It is basically 300 students. There are 2 sets. The first set A is basically the set of students who are 30 or older. The second set B is basically the set of students who have no high school diploma. Okay. How many are there in the overlap of these two sets? So there are 1, 2, 3, 4, 5 such symbols. So each symbol is 10 students. So 5 symbol means there are 50 students. Here you have 4 symbols. So this is 40. Here you have 1, 2, 3, 4, 7 and 10, 11. So you have 110 students as such. Outside you have 3, 6 and 10. So there are 100 students that are not part of either set as such. So I'll write my 100 over here. Now is this all adding up? See this, if I consider A or B, it is 110 plus 50, so 160 plus 40, that is 200, 200 plus 100, 300. So this is a correct Venn diagram. It is showing every one of the 300 people, whether they are 30 or older, whether they have a high school diploma or they don't have a high school diploma. This is no high school diploma. This is 30 or older. Okay. Now let us take a look at the questions that are asked. See, basically anything outside of the set A. So this part outside of the set A will be all the students, this part also, all the students who are younger than 30. So this part, this 110 plus 60, 160 students are 30 or older. The remaining 140 students are younger than 30 as such. Similarly, I'll remove this. So these, how many have no high school diploma? This 50 plus 40, these 90 have no high school diploma, which means that everybody else over here, this area over here, which is like 210 students as such, these 210 students do have a high school diploma. So high school diploma is 210 students. Under 30 is how many students? That is 140 students. Okay. So this information I can infer from the given figure as such. I'll just remove the shading so it will be easier to read and I'll write it again. So under 30 is 140 people and high school diploma, the high school diploma is with 210 people. Now the question that is asked based on this Venn diagram is, using the drop down menus to complete each statement according to the information presented in the diagram, if one student is selected at random from the 300 surveyed, the chance that the student will be 30, under 30 or a high school student or both is, so how many are under 30 or high school student or both? So basically under 30 is basically A dash, okay, or high school graduate, so that is B dash, or both as such. So A or B, essentially A dash or B dash you want to choose. A dash on B dash is what essentially? It is basically the union of A dash is this part, right? A dash is this part as such. And B dash is what part? It is this part. I'll put like say, I'll put it in the opposite direction. This is B dash. So which part is essentially not included in A dash or B dash? This part over here, which is essentially A and B. Other than A and B, everything is included in A dash or B dash, because either it will be part of the A dash or B dash. So the only part which is not part of either A dash or B dash is essentially the intersection of A and B. So apart from this 50, everybody will be part of under 30 or high school graduate or both as such. So out of these 300, apart from these 50 over here, everybody would be in this particular bracket as such. So 250, that is 300 minus 50 would be satisfying this condition. So 250 out of 300 would satisfy this condition. So what would be the probability? 250 by 300 is 5 out of 6. So 5 out of 6 students will actually satisfy this given condition. So the correct option to choose is 5 out of 6. Now consider the second statement. If one student is selected at random from the 300 surveyed, the chance that the student will be both under 30 and high school graduate is what? So you want both under 30 and high school graduate. So under 30 is A dash and high school graduate, that is B dash. You want A dash and B dash. Now if it is A dash and B dash, this part over here, which is the part inside A and inside B, get eliminated. So this 110 can no longer be counted. This 40 can no longer be counted. You have to only count the part which is outside of A and outside of B, which is basically external to A and B set, which is essentially your set N, which is not part of either set as such, which is 100, which means that these 100 are both under 30 as well as 100 high school graduates. So 100 out of 300 would be how much? What would be the probability of selecting one out of these 100 out of 300? That would be 100 divided by 300, that is 1 out of 3. So the correct option to choose would be 1 out of 3. So here you needed basic ability to read the chart, convert it into a Venn diagram, and once you had converted into a Venn diagram, read the different parts of Venn diagram and calculate basic probability. That is all that was really required. In graphics interpretation, the set theory and the Venn diagrams that come are very basic. You just have to convert them into basic 2-set or 3-set Venn diagrams, and then you will be able to solve the questions based on them. Now let's take a look at the next type of quantitative diagrams that come, which are network diagrams. So network diagrams are basically a visual representation of a network. What is a network? A network is basically a connection of nodes. So when you have nodes connected by either links or roads or say wires, that is essentially a network diagram. Suppose you have say 4 nodes A, B, C, D, and each of these links represents a wire. So A, B, C, D are say 4 computers, each of these are wires connecting the computers. So this diagram is essentially a network diagram. So suppose A sends say 10 bytes to B, B sends say 5 of these bytes to D and the remaining 5 bytes to C, and say C sends back say 2 of the 5 bytes it receives to D. So using the network, using the interconnection, you can say that D receives 7 bytes from A. B receives 10 bytes and gives out 10 bytes. C keeps 3 bytes with it, 3 bytes of information with it. So essentially using this network diagram, I can show the flow of information, flow of things through a particular network. I can show what are the different nodes in a particular network, how are they connected. Now where would you use this? There are multiple ways in which you can use this. One way you can use this is in a geographical sense. So you can consider instead of nodes, you will have cities. So these are the cities and these are the roads connecting the cities as such, and you have to figure out how much time it would take to actually go from city A to city B. Or these can be cities A, B, C, D, E, and these can be the flights connecting from A to D and say D to B, B to C, C to D, and say A to B and back from B to A, and say A to E and E to A. Both of these can, a network diagram can essentially show any flow or interconnection between different nodes. The nodes can represent geographical places, it can represent tanks and pipes. So this can be pipes, A, B, C, D, E can be pipes, can be tanks, and the links between them can be pipes showing the flow of water from one tank to another. So essentially it's a visual representation of interconnection of different things, interconnection of cities, interconnection of tanks, interconnection of computers, and basically what is the flow between one part to another as such. You have to use these diagrams to calculate how much information is flowing or water is flowing, or how much time it would take to go from one city to another, or how much money it would cost to go from one city to another. I'll show you an example of a network diagram and we'll solve it so that you get a better understanding of what a network diagram is. So consider the following network diagram. It is told to us that the given diagram shows the road infrastructure joining 3 towns A, B and C. So these are the towns A, B and C and 4 villages M1, M2, M3 and M4. 2 different types of roads connect the cities and towns: highways which can accommodate cars, buses and trailers, and smaller roads which can accommodate only cars. So this thinner ones are smaller roads. So A to M1, A to M3, all of these are connected by smaller roads, and the 2 metros A to C and A to B are connected by a main road as such. So main roads are basically highways. The number next to the road indicates its length in kilometers. The cost of traveling on a highway is $6 per kilometer for a car and $8 per kilometer for a bus. The cost of traveling on a smaller road is $10 per kilometer for a car as such. So the lowest cost to go in a car from B to C is -% more than the lowest cost to go in a car from M1 to M3. So what is the way in which we can go from B to C? See, to arrive at C, we can either come from A or from M4, and both are connected to B as such. So either you can go BAC or BM4C. These are really the most logical paths possible. You can also go, I guess you can go BAM2 M4C, but it would not make sense because we are trying to find the lowest cost, and if we actually take more circuitous routes, we will be increasing the cost as such. So if we were trying to minimize the cost, we would take direct routes either BAC or BM4C. Now if you are going BAC, in this case we are using the highway throughout. The cost of traveling on a highway is $6 per kilometer for a car. It is 6 plus 7, so there are 13 kilometers on this particular route, and $6 per kilometer, it is $78 as such. So this route BAC costs how much? It costs $78 as such. Now consider BM4C. It is the cost on a smaller road is $10 per kilometer. So you have to go 2 kilometers plus 6 kilometers, that is 8 kilometers. So that would be 2 plus 6, that would be how much? That would be 8. So that would be $80 as such. This is $80, this is $78. So the lowest cost is what? This is the lowest cost. So this is $78 is how much more than the lowest cost to go from a car from M1 to M3. Now let's do the same thing for M1 to M3. To go from M1 to M3, we can either go directly over here, M1 to A to M3, or we could go M1A, M2, M3, or we could go, other routes is M1B, M4, M2, MA and or directly to M3 or through A to M3. But essentially all the other roads are rather long-winded unnecessarily. There's only one logical road that you should essentially take, which is M1A, M3. So there is only one road which is M1A and M3. It is 3 kilometers plus 3 kilometers, 6 kilometers, and each of these is for a car is 10 kilometers, $10 per kilometer. So that is 60 kilometers as such. So this is 6 kilometers into $10 per kilometer. So this is $60 cost. So how much is 78 more than $60? The difference is 78 minus 60 by 60 into 100%. So that is 18 by 60 into 100%, which is equal to 30%. So the correct option to choose is 30%. The lowest cost to go from in a car from B to C is 78, which is 30% more than the lowest cost to go in a car from M1 to M3, which is $60. So the correct option to choose in the drop down would then be 30%. So basically you have to solve it in this way. You have to count things, you have to calculate how much money it would take, how much time it would take, how many kilometers have to be traversed. If it is water, how much water will flow, how much time it would take the water to flow. Many things can have to be calculated, but essentially the way to calculate remains same. You calculate, read along the graph, okay, read along the network, okay, this is 3 kilometers, this is 3 kilometers, it would be a total of 6 kilometers into 10, 60. So basically the thing is nothing really, there is no way to or like method to solve it. You have to read the network, you have to follow paths along the network and calculate different things for each path. Sometimes multiple paths are possible, then you have to exhaustively list down all the paths possible and calculate for each path what is the idea. Sometimes some paths will definitely not make any sense. If you are looking for lowest cost, taking the longest routes will not make sense. So just consider the direct paths in such cases. But the idea remains the same. Consider the paths, consider all the paths, consider only the sensible path, calculate for each of the sensible path till you find the lowest value or the highest value or whatever is applicable. So essentially you have to take the network diagram, convert it into the relevant list of paths and calculate the required values for that particular list of paths as such, and then you will be able to get the answer as such. So this is how you solve questions on network diagrams. So we have covered in this particular video Venn diagrams and network diagrams. These are the two important quantitative diagrams that come in GMAT FE. So now that you know, I want you to actually revise more questions from this particular topic because these are very easy to solve graphics interpretation questions. You should definitely not get them wrong. So this is how you solve questions of this particular type. I hope to see you again for part 3.